All right, guys, we're back with section 6.5. Now we're going to talk about applying systems of linear equations. So, up to this point, we've solved systems of equations using substitution and elimination as well as graphing. Now we're going to determine the best method for solving systems of equations and also apply those methods. So, that's what we're going to talk about, solving systems. So in speed skating, competitors race two at a time in a double track. Indoor speed skating rinks have two track sizes for race events, an official track and a short track. The total length of the two tracks is 511 meters. The official track is 44 meters less than 4 times the short track. The total length is represented by x plus y, so that the length of the official and short track, add those together, you should get 511. Now, the length of the official track, remember they said is 44 meters less than 4 times the short track. So it's 44 meters subtracted from 4 times the length of the short track is equal to x, which is the length of the official track. So we can solve that system to find the length of each track. Now the question is, which method should I use? All right. So we've learned 5 methods for solving systems of linear equations, actually, if you break it all down. We've learned graphing, substitution, elimination using addition, elimination using subtraction, elimination using multiplication. And I will tell you that these 3 elimination methods all are using the idea of elimination. Okay, all 3 of those are elimination methods. That's why they're called elimination. So really there's 3 methods. There's graphing, there's substitution, and there's elimination. Okay, you just got to know which elimination method to use based on how the systems are set up. So substitution and elimination are algebraic methods for solving systems of equations because you have to kind of like solve the equations. And that's best if you need an exact solution. Graphing, whether you use a graphing calculator or just graph by hand, is a good way to estimate the solution, particularly if you're getting answers that are not integers. Okay, because it's really hard to estimate a point on a graph that's a decimal. Okay, this example, to solve it with the speed skating, I would use substitution because one of the equations is already solved for x. All right. So a system of equations can be solved using each method. So to determine the best approach, analyze the coefficients of each term in each equation. So what's the best method for this one? And then we're going to solve the system. Well, what do you think? You got 4x minus 4y equals 8 and negative x plus 4y equals 19. To determine the best method, look closely at the coefficients. You got 4, negative 8, and y. Neither the coefficients of x nor y are the same or additive inverses. In other words, they're not both 4s or they're not both opposites. So you can't add or subtract to eliminate a variable. Since the coefficient of y in equation 1, since the coefficient of y in the second equation is 1, you can use substitution. In other words, this equation is very easy to solve for y. Just add 8x to the other side. Then you have y by itself. Then you could substitute. Okay? So I will say that if you're trying to determine which method to use, there's not like really a wrong answer because elimination or substitution will always work. It's just which is going to make it easier to solve. Sometimes using a substitution, when you solve for y, you end up with fractions and negatives and different things, and it gets more complicated. Sometimes if you're trying to use elimination, if you have to multiply both equations, sometimes you might end up with very large numbers that also make it difficult. So you just kind of got to use whatever you feel more comfortable with. Somebody might have said, oh, I'd like to use substitution with this one because I noticed my y's have opposite signs, or my x's have opposite signs, and if I just multiply the first equation by 2, then I can get the x's to cancel. That could very well have worked, and it would have been right. But we're going to use substitution just to kind of review it. So add 8x to both sides, and you get the second equation in terms of y. and then substitute that in for y in the first equation. Make sure you put parentheses around it because you're multiplying -4 times what you substitute in for y. So then distribute the -4, combine like terms, add the 76 to both sides, and then divide both sides by -28, and you get x equals -3. Once you know x equals -3, you could substitute that in either equation. I would use the second one just because it's easier, because y is already by itself, or y has a coefficient of 1. So I plug in -3 for x, and simplify, you get y equals -5. So the order pair is -3, -5. All right, here's 4 for you to try. Now, you don't have to work through each one, but just try to figure out which method would work better, and then if you want to solve them, go ahead and solve them. All right, pause the video. All right, we're back. What'd you get? Oops. So the first one, I would use elimination because the 7s, the y's both have a 7 in front of them. So you would just multiply the second one by a -1, or you could just subtract them and solve for y. In 1a, the solution is going to be -1, 1. For 1b, again, I would use elimination there because you could multiply the first equation by a 2 and then cancel the y's, and you should get -2, 1. 1c, you could use elimination or substitution. Doesn't really matter. I mean, you could use elimination or substitution for all of these, but which one's going to be easier? And this one, I think it's kind of a tie, because if you added these two together, the y's would cancel. Or if you added the y to the other side of the first equation, you would get x by itself, and you could substitute and solve for there. So I'm going to put s or e, and the solution for that one is 2, -7. And the equation D, I would use substitution for that one because y already has a coefficient of 1. So you just solve that for y and substitute it in. And the solution for that one is 3, -2. Okay, hope that was helpful to you, and stay tuned for the next video, and we'll finish out this section. See you there.